So, Peter, I'd like to start with a little bit of an explanation of what beamforming is. We're going to get more into it as we go, but I think as a starting point, we're going to talk a little physics here.
Okay. Yeah. So beamforming is a very interesting phenomenon in acoustics. You find it also in other scientific pursuits. For example, a lot of beamforming theory was developed around radar in the 30s and 40s. But in acoustics specifically, beamforming refers to the ability to delay and sum waveforms such that we control the shape of a wave in 3D audio space. In other words, in acoustical space. So the classic example of that is if you think for a moment about a sine wave. Of course, a sine wave is an S-shaped wave on its side, which
the simplest possible waveform, really.
That's right. That's right. Yes. Contains no harmonics and emits a very pure tone. So if I add two sine waves together, I get, as you might expect, an increase in the amplitude or the volume of those two sounds as they mix acoustically. However, if I delay one so that it's exactly 180 degrees out of phase, so essentially I have a positive going wave as well as a negative going wave that combine in space together, what do you think I'm going to get there?
Well, I would say nothing.
You would get nothing. So, in fact, the first example that I explained there is an example of additive acoustical summing or constructive waveforms. And the second would be destructive waveforms or destructive phase relationships. So two out-of-phase signals can cancel each other. So
which is in fact how active noise-canceling headphones work.
That's right. That's right.
Although it's on more complicated waves than sine waves.
Yes, it is. Although you'll notice that active noise-canceling headphones tend to be more effective in low frequencies than high frequencies.
Also in steady state rather than in time-varying sound.
That's right. Yeah. So, at any rate, we can control wave shapes. We can control amplitude by controlling the phase and time domain and addition of two waveforms in space. And it turns out that that there's a lot that you can do with it. One example, as you mentioned, is controlling noise. So there's something in acoustic theory called anti-noise, and if I add noise plus anti-noise, and I'm very careful about the phase alignment of those two signals, then in fact I can cancel noise. And that's exactly what's happening in our noise-canceling headphones, which companies like Bose and others have introduced and are extremely useful. So
I would never go on a plane without mine. That's for sure.
Me either, especially the long hauls. I mean,
yeah,
right. Yeah. So, in fact, I'm wearing the Bose right now. It's there's a fair amount of HVAC noise in my office here at UCSD, and I'm hearing none of it. It's quite quiet within my little cocoon. What's happening here is I've got a little microphone on each headphone. It's listening to the environment, and it is producing an out-of-phase copy of the signal that's going into the headphone. Is mixing that with the acoustic sound that is leaking into my headphone from the environment and from the slight leakages around the earpieces. Those are adding together and radically lowering the noise that's reaching my ear canals by probably 30 dB or so.
Exactly.
So turns out there's some interesting things that you can do besides noise cancellation and radar. One of them has been exploited for many years in audio PA systems. So think about the PA systems that you've seen in a big live concert. You'll notice often that the speakers are trapezoidally shaped, and they're put into a series in which there's a careful angular relationship. And that generally is a kind of arcing relationship that swings down from ceiling to the middle of the auditorium and progressively swings away from the audience. And what you're getting there is some beam forming, so you get very solid coverage in the area that needs coverage, and you're also eliminating a fair amount of leakage on the on side beams. And that's an example of a simple kind of mechanical beamforming that is used in PA audio.
Isn't that interesting? I hadn't realized that. I've seen those big PA systems with the line array essentially of speakers
Yes.
that curve away from the audience, but I had no idea that was a rudimentary form of actual beamforming.
Yes.
Pretty cool.
And as audio technology in live sound becomes more and more complex and benefits more and more from signal processing, you'll find that there are smart sound servers and signal processors behind the systems that allow the engineers to tune the system so that you get excellent coverage, you get equalization where there might be dips or peaks in equalization. But in fact, there is some increasingly sophisticated active beamforming that takes place.